everybody's itching to hear about, you know, problem of the day. And we've got Martina on the job here today. She has bought 20 used books at prices of either $3 or $5. Nice deals there, I agree. Spending a total of $86. Now the question is, how many books did she buy at each price? So basically two important things here, two important totals. We got 20 books and we're spending $86, and the price 3 and 5 is fixed. We can't do anything about that. And basically it looks like we can't do anything about 20 and 86. So let's see how we're going to work through this problem and find out how many there are. Now I've had a few people on Facebook already kind of showing me some answers and stuff there, and some are right, some are wrong, but we'll take a look and see which one works out right. First of all, I want to use one variable. You say, can you use two variables? Well, a lot of times when we're looking for two things, we think of using x and y. Well, we can also use x and, well, you wonder what else we might use. Well, let's figure that out. But let's let x be, you know me, I love those x's, don't they? Unknown part here. X equals, how about it, the number of $3 books. Straightforward. And we didn't say why, did we? But what are we going to represent the number of $5 books as? We're going to do a little algebra on this. Now, some of you are already probably thinking in your head combinations of 20, and obviously you can't have half a book or a quarter of a book. So maybe 5 and 15, 14 and 6, those kind of things. But let's play it out in algebra, and we'll go right to the source rather than having to do so many. Well, we add these together to get 20, but boy, we have to multiply things out to get to 86. That's a little bit tougher part of the clue. So here's what we're going to do. We know there are 20 total. I mentioned 15 and 5. What if I know there's 5? How do I get to 15? Simple question, isn't it? We subtract from 20. What if I had, let's say, 11 and 9? I had 11 of one. We subtract it from 20, again, we get 9. So what we're going to do, we're going to say the second type of book, we're just going to say it's 20 minus whatever our x chooses to be. Whether it's one book up to 19 books, goodness, it could be all, it can't be all 20. You know why? Because, well, you can figure that out yourself, right? It's very simple. It's got to be a combination in between, because 5 times 20 will give you $100. 3 times 20 gives you 60. That's not quite there. So that tells me it's somewhere between 60 and 100. Then it's got to be some balancing going on in between. So let's see what happens. We have, by the way, these are the number of $5 books. Now keep in mind, the value of the book is important. It is very important. And in fact, what we're going to do, we're going to say the amount of money that Martina put down for the $3 books was 3 times that x. In other words, if she bought 10, she multiplied it by 3. That's her cost. That's her cost. The next piece is she did $5 for these other guys. So 20 minus x. And when she got through her spending spree here, she was up to $86. Does that make sense? Cost of your $3 books plus cost of your $5 books gives you $86. That's the logical process we want to go through. Don't let these things be scary to you. There's usually some sort of nice way to think logically as to how the pieces fit together. Here it's cost plus cost gives you cost, and we've already set up the x, and that 20 minus x is the key feature right there that allows us to, yes, it allows us to pick up very easily on a way to name how to do the $5 books. Now, let's distribute. We can't do anything with 3x, but we'll bring it down for the ride. Let's distribute. How about it? 5 times 20. There comes that 100 we mentioned earlier, but it's going to go away because we're going to lose some of it. We're going to take off 5 times how many ever our x represented here, 5x. And now we equal to 86. Life is good. It really is, because this is going to work out very, very nicely for us. First of all, let's put our like terms together here. Yesterday we mentioned that kind of river thing. You can't jump over the equals, all right? It's kind of like a little river flowing through there. We have negative 2x plus a 100 equals to 86. Already this problem is looking so much easier, isn't it? And we're going to move that 100. This time we do have to subtract when we move it to the other side. Subtraction property of equality ruling for us here. And now things get to look really nice and easy. Negative 2x equaling to a negative 14. Comes out even. It has to come out even, right? Remember what I said? You either have a book or you don't. And x equals to 7. Now, what does that 7 represent? What did it represent? Go back up here to our original. That's why we define our variables, folks. That's why we say what we're talking about with x and this 20 minus x. That is how many $3 books we had. Now, 7 times 3, that's going to give me what? $21 I'm spending. Let's go to the next one here. Hey, if it's 20 minus 7, it's got to be 13, right? I mean, you've got to take 7 from 20. That's going to give you 13. Now, multiply your 13 times 5. Can you do that mentally? I'm going to try. 65 is what I'm getting. And you know what? I like this. Oh, what a perfect moment right there. These check back together. 21 plus 65 gives you 86. So let's go with 7 at $3 and 13 at 5. I hope you all got it right out there. And again, check us out on Facebook.